Assalamualaikum, and today our group from group number 10 COVID Buster. Okay, today we will present to you this our project. Our project is disinfection tunnel. Okay, first of all, our group consists of three group members. The first one is Nur Fashiha binti Muhammad Rashid. Second one is me, Muhammad Hafiz bin Mansur. And lastly, Nadira Arifah binti Yusuf. Okay, slide contains introduction, problem statement, objective, result, and analysis, and lastly, recommendation for future work. Okay, okay, the pandemic of coronavirus disease in uh, cor- in 2018 has resulted in an unexpected high number of hospitalization for pneumonia with multi-organ illness. Okay, so how this virus spread? Okay, this virus can infected people by okay, the common way is it through person to person. Okay, by when that person touch the contaminated surface, let's say if that person having a maybe the person already has that virus, and that person touch their mouth, and maybe their mouth or their nose they touch, and then the infected person touch let's say touch table, and you come to that person, you the area also, and you touch the table, so and then the virus spread to you. So that's how this virus spread. Okay, our solution for okay our solution for this to help reduce the spreadness of COVID-19. Okay, we propose an idea to do disinfection tunnel for to helps an external disinfection for user. Okay, when this tunnel we place entrance of the mall or building.
Problem statement. The outbreak of the COVID-19 virus has affected countless people all over the world. Controlling this real-time pandemic is now a major priority of the scientific community. People can get infected from this virus in many ways, mainly from the person to person. This new creation can help as much as it can do. Perform countless disinfection of exterior surface. This is the objective of this project, which is to design a device that could be helpful to prevent the further spread of the COVID-19 and to facilitate immediate disinfection. Next is the summary of the literature review. This is summary article for IoT-based UV disinfection machine. This paper talks about how UVC tubes can be used to kill different kinds of bacteria, spores, and fungi. Their goal was to make sure the UV light was always in the same place, at the same time, at the same distance, and for the same amount of time. In the paper, they say that the tubes work up to 8 feet from either side tube and suggest leaving it out for 30 minutes to make sure it's in. This is the rough diagram of this project. This is summary article for IoT-based sanitization tunnel. An automatic walk-through sanitization tunnel. It uses sensor to detect the target and automatically disinfects it, followed by irradiation using UVC rays for extra protection. Also, they add an IoT-based temperature sensor and data relay modules used to detect the temperature of any person entering the tunnel and in any case of any anomaly. This is the diagram for this project. And the last summary article is Autonomous Disinfection Robot. This research paper is about a robot that can solve this problem in a consistent and quick way by using a vacuum, a sanitizer mop, and UVC radiation to kill germs. Also, the machine can work both automatically and manually, so people don't have to be directly involved in the dusting process because it has two ways to control it. This self-regulating machine can go on both simple and complicated tracks. This is a diagram of autonomous disinfection robot. Okay, this is flowchart of our project start. Next, human detect, and then reading temperature. If temperature above 37 cannot enter, and if temperature below than 37 enter, and disinfection spray. Next, UV slide and
Okay, for result and simulation part, let me pause and this first. Okay, for result and simulation part, okay, first of all, let me explain this. Okay, this one represent as a fan in our tunnel. Okay, and this for LED red represent as a disinfection spray, and for LED green it represent as a UV light. Okay, this sensor, it is ultrasonic sensor, not IR sensor. Sorry, there is typo. Okay, we use ultrasonic sensor. Okay, let me show the simulation first. Okay, as you can see right here, when user enter the tunnel, there is a certain range. That sensor we already set the certain range. The sensor to detect person user entering the tunnel that we set is 100 centimeter range, the 100 cm and above. Okay, if sorry, not above, less than 100 centimeter. Okay, if the sensor if that user above the 100, the sensor will not detect the person. Okay, as you can see right here, the person range is 163.7 centimeter from the from sensor, and this thing fan disinfection spray and UV light will not go on. Okay, okay, okay. When the sensor already detect that person, all of these thing will be go on. Go on. Okay. Okay, okay, you can see when the person already go out from the tunnel, all of these will go off. Okay. Next for the calculation part. Okay, how IR sense ultrasonic sensor work? Okay, how the sensor work is actually the sensor will detect the signal through receive and transmit. Will receive the signal that transmitted by sensor. Okay, let's say there is a object in front of the sensor. It will send a signal to receiver, and receiver will detect the range. Okay, actually ultrasonic sensor it use speed of sound formula. It is because it emit ultrasound at 40,000 hertz, uh, which is which travel through the air, and it will bounce back to the module. It will bounce back to the sensor. Receiver will get the signal. Okay. This is the formula. Okay, speed. equal to 340 millisecond equal 0.034 centimeter. Okay, to get the time, we need to divide by distance. Distance the sensor detect uh, divided by speed. Speed is 340 millisecond. And to calculate the distance, okay, we will be using this formula: speed times with time divided by 2. Okay, this one is a maximum range that we use in our tunnel. Okay, 100 centimeter. How to calculate the this one is show times the sensor detect that person delay times sensor detect person. Okay, they did issue right here 100 centimeter divided by 240 millisecond. It will and we will get the time delay 0.29 millisecond. Okay, for minimum range, I already said is 20 centimeter. Okay, so the time delay for sensor detect, it will what we'll get is 0.0 millisecond. Okay, okay, I think that's all for my part. Okay.
Okay, this is our recommendation for future work. Number one, first we would like to use low-cost ultraviolet radiation. Next, we want to use material that easy to store and easy to handle. And the last one, effectiveness study of disinfection tunnel. Okay, as you can see, this is our expected outcome for our project.
That's all for us. Thank you.